Hey everyone, in this video we are going to talk about logarithms. Logarithms are the inverses of the exponential functions that we've been talking about in the previous video. So let's go ahead and take a look at how these work. I want to start by considering something that has nothing to do with logarithms, but it kind of gets us thinking about how they might work. All right, and so this thing is the following equation: x cubed equals 7. Okay. So how do we solve this? Well, I know exactly what to do. I'll just take the cubed root of both sides to find x. So if x cubed equals 7, we know that x equals the cubed root of 7. Now, we're fine with this. We know that the cubed root of 7 is a number. It's the number that when cubed gives 7. Let me write that down. It's the number that when cubed gives 7. And we know, we could probably even surmise roughly what value that might be. And I know that 2 cubed gives 8, so it's a number a little bit less than 2, right? 1 cubed gives 1, so it's a number between 1 and 2, probably closer to 2, right? So we have an idea of where this number is on the number line, and we could use a calculator to get its decimal value. Okay, well, what if I gave you the equation 3 to the x equals 7? How are we going to solve this? Well, this is where logarithms come into play. Okay, and the answer is, I'm going to go ahead and tell you the answer. It's x equals log base 3 of 7. And so what does that represent? It represents, it's the exponent on 3 that gives 7. That's what x is, right? X is an exponent on 3 and it produces 7. Okay, the exponent on 3 that gives 7. So this might look really mysterious to you right now, but that's because you're just not used to it, right? Cube root of 7 is very mysterious to people. What does this symbol mean? Where does that come from? If you've never seen this symbol before, this is going to blow you away. It's going to look like, whoa, what the heck is that thing doing? What is that about? But when you get used to it, you come to terms with the fact that it means this. And then we can get an idea of what number it represents and where it is on the number line. Well, we're doing exactly the same thing. We're using some new symbol. Instead of this funny shape here, we're using this word, log, with a little subscript here. And notice how, just like we wrote the 3 over here, we're writing the 3 down here. So it's really and completely analogous to this. So how do we do this? How do we write this in general? Well, if I tell you that y equals b to the x, right, then if I wanted to solve this for x, right, I would write x equals log base b of y, right? X is the exponent on b that gives y. All right, so that's how we're going to interpret this. Whenever we see this expression, we're going to be thinking about it that way. Okay, so let's look at some examples. So here we go. Log base 2 of 8. What is this? It's the exponent on, what's the b here? It's 2 that gives, what's this number here? 8. It's the exponent on 2 that gives 8. In other words, 2 to the what equals 8. Think about it a little bit, you realize that's the number 3. So that's what log base 2 of 8 means. Okay, what about log base 4 of 16? Well, it is the exponent on 4 that gives 16. So 4 to the what equals 16? Well, the answer is 2. What about log base 10 of 10,000? Well, that's the exponent on 10 that gives 10,000. 10 to the what equals 10,000. Well, I know that the exponent gives me the number of zeros here, so this must be 10 to the 4th. So logarithms give you exponents. When you're asked to find the logarithm, think exponent. I'm finding the exponent. Let's do some more here. Okay. Well, log base 10 of 0.1. So what's the exponent on 10 that's going to give me 0.1? Well, what's 0.1? That's 1/10. What sends 10 to the denominator? A negative exponent. And it didn't change, so it must be a -1. 10 to the -1 is 0.1. What about log base 2 of 1/4? What's the exponent on 2 that would give me 1/4? Well, I know that 2 squared gives me 4, but I need it to end up in the denominator, so it must be a -2, right? Positive 2 would give me 4, -2 would give me 1/4. That's what negatives do. They send it to the denominator. Okay, so this is how logarithms work. Takes a little bit of getting used to, but this is how we compute them. Always remember that the logarithm is an exponent. You're trying to find the exponent.